All right, 4 families are meeting up at Disneyland. Each family starts driving from home. The representation below shows the distance each family is from Disneyland over time. And yes, X is time in hours, Y is distance from Disneyland. That's good to know. Assume the families drive to Disneyland at a constant rate, which makes this very convenient. So part A, B, C, D, and E, and F. In order to figure these out, we need to figure out their speed, but also the y-intercepts. A and B are about y-intercepts. Which family lives closest to Disneyland and which family lives the furthest. That's going to be our y-intercept. Because the y-intercept for these ones is going to be at 0 something, like this. And the B value, the y-intercept, will tell us how far away they are. And the speed in these ones, we're going to see that they're negative because they're getting closer to Disneyland. And the speed, of course, is the slope or the rate of change. So that's parts C and D. That's talking about speed because both of those are rates. Speed is always a rate in distance to time. In this case, it looks like we're dealing with miles to hours ratio. And then part E and F is kind of our x-intercepts. We'll just see who gets there first, which means the distance would be 0. We'll get to those. So family A, I would actually change the way this equation looks so it's in slope-intercept form. Y equals mx plus b, and we can see the m here is negative 55, negative 55x, and then would have positive 95. Okay, so I just changed the format a little bit. I just switched the 2 terms. But this also tells us the rate they're going, m, which is 55. I should put this down here, 55 miles per hour. And I'm not making that negative because that's the speed they're driving at. It's negative. It's a negative slope because they're getting closer. And then, of course, the y-intercept here, that's going to tell us how far away they are from Disneyland to start out with. So that'd be 95 miles away. All right. So we assume this is how far away they live. That's okay. Part B says they live 120 miles from Disneyland. That, by the way, is the y-intercept there. So that'd be 0, 120. And they're driving at 60 miles per hour. Well, that's already the slope or the rate of change. It's 60 miles per hour. So just from these 2 families, we can see that family B, they're traveling faster by 5 miles per hour, but they also live farther away by 25 miles. But we need the other families as well. So family C, in fact, the table gave us the y-intercept, so that means this family lives 80 miles away. And the table will tell us the slope as well, or the rate of change. So they're going to go 80 to 5, that's 75 miles. And from 0 to 1.5 in hours, that's 1.5 hours. So as a ratio, it's negative 75 to 1.5. And if we simplify this, it'd be 50 miles per hour. And again, you can do that in the calculator. Just do negative 75 divided by 1.5. So family C, we see their speed and how far away they are. And in comparison to families A and B, they're going, looks like the slowest. Yeah, we don't really need the negative on that, 50. They're going the slowest, but it looks like between the 3 families, they also live the closest. So let's look at family D then. Family D, we have a y-intercept. That's just where the line goes through the y-axis. That's at 0, 45. And then the other ordered pair that I see is this one right here. That's at that's 1 hour and 5 miles. All right, but the y-intercept, yeah, that tells us 45. They're 45 miles away to start. So that's probably how far away they live. And then after driving for 1 hour, they're 5 miles away from Disneyland. Okay, so to find the slope on this one, we're going to use the slope formula. And we got the ordered pair 0, 45 and the ordered pair 1, 5. So this would give us the rate of change. That looks like it's negative 40 to 1. That's 40 miles per hour. So they're traveling at 40 miles per hour. And we can also see, well, I guess we'll get to that next part. So just from this information, we should be able to answer those first 4 questions at least. So which family lives the closest to Disneyland? So yeah, family A, that's 95 miles. That's closer than family B, but it's not as close as family C. They're 80 miles away. Family D, though, they're only 45 miles away, so they're the closest. Family D is the closest. Family that lives the furthest, that's B, they're 120 miles away. But speed on this one, that's our M, or the rate of change of the slope. And yeah, it looks like the family going the fastest here is 60 miles per hour. We got 55, 50, and then 40, so yeah, 60 is the fastest. And that also is family B. So they are going the fastest, but they live the farthest away. And then which family is traveling the slowest? Yeah, that's family D right here with 40 miles per hour. So family A had 55 miles per hour. Family B, 60 is the fastest, and then 50 for family C. So 40 miles per hour is the slowest. So who will get there? Who's going to get to Disneyland first? Let's go through each family and figure that out. So family A, I'm going to use the equation to solve this one. That's y equals negative 55x plus 95. When I solve this, it will tell me how far or how long it's going to take them. Well, to figure out how far they are from, or how long it's going to take to get to Disneyland, that means their distance would be 0. Once the distance is 0, then they're at Disneyland, right? So I'm just going to solve this equation. I'm going to subtract 95 from both sides. It's just a 2-step equation. So I got negative 95 equals now negative 55x, which we dropped. 95 minus 95 is 0. That's good. Divide both sides by the coefficient of x. Let's make that a phantom 1. And x, that's how long it's going to take. 95 divided by 55. I'm going to use my calculator for that. Got 1.72, 1.73-ish. I'll just put 1.7 hours. So that's family A. It's going to take them 1.7 hours to get to Disneyland. Family B, I can do the same thing because we have the slope and the y-intercept on this one. The slope was 60 miles per hour. You can even put negative 60 to show they're getting closer. And they're starting at 120 miles away. But again, we want to know when that y value is going to be 0, because that's the distance from Disneyland. Well, subtract 120. Not everyone needs this. Some of you know it's just 2 hours, and that's fine. So it's a negative 120 equals negative 60. That's a negative 60x. Divide both sides by negative 60. And x, that's going to be 2 hours. So family B is going to take 2 hours. Family C, we can do the same thing with the equation stuff. So on this one, y equals mx plus b. Yeah, the m there is negative 50 because we're getting closer. But again, we're looking at how long it will take for the distance to be 0, and the y is distance. So solving this one, subtract 80 from both sides. Divide both sides by the coefficient of x, negative 50. That tells us x. Just put this in the calculator, you get 1.6 hours. So family C is looking at 1.6 hours to get to Disneyland. Family D is not so bad because this is a graph. We're just looking for where the distance is 0. That's the x-axis. That's right here. I'll use orange. That to me looks like it's about 1.1 hours. And we can't estimate that because the other values aren't even close. So looking at these times for how long it will take the families to get there, who's going to get to Disneyland first? It looks like family D will, even though they're going the slowest. Part of that, of course, is because they live the closest. And then who's going to take the longest? Yeah, it looks like the 2 hours for family B. That's going to be the longest. So family B, again, they're traveling the fastest, but because they live the furthest away, yeah, it's going to take them the longest to get there.